Hello everyone. In this video we're going to try to use some of the tools we've learned to create a hinge for usage in various objects. Right. One of our projects is going to be making this a storage box, jewelry box type thing, a container of some kind that is a hinge joint, at least one hinge joint somewhere on it. And I had shown you my example, and I'll just briefly open it up again just so you can see this simple design. We can see there's the hinge. In this case, there are two parts of the hinge. The top, if I hide the top, we can see that and I'll hide the pin as well, you can see the bottom part of this thing has three of the hinge connectors on it. And if I show the top and hide the bottom, you can see the top has two. The combination of both of those when they're lined up properly is 5. And then down that middle of the hole, we can see that we want to have a pin that connects them so that way they're connected as one piece and they can rotate around that, right? And so that's the pin. And we could put outer points in the pin so it's easy to grab, but it's not really necessary. Once the pin is in, typically these things are metal, but even if they're plastic, the idea is that the pin stays in between all the different hinge pieces and holds it as one unit, right? So we'll do this with just simply kind of a flat surface. We won't make a complex shape to attach them to. Really the goal is to kind of see the idea of how can you make a simple hinge and recognize there are many types of hinges that have many connectors. This is a typical 5 connector hinge, but there are some that are just 3. Depending on how heavy the thing is, depending on how much you want it to rotate, you can get away with fewer or more connectors. Right? If you need more strength, more support, if you expect it to be a heavy lid or a heavy rotation, doors often have between 3 and 5, depending on what you're looking at, and that's enough to hold the weight of metal doors and wooden doors and so on. But that's more the kind of physics of it. For our purposes, if we're going to be 3D printing prototype models, really, even 3 might be enough for a lot of situations. It just depends on what you're trying to do. And of course, the aesthetics of what you're designing might also have an impact on how complex your hinges look. Right, so we're going to try to recreate this on just kind of 2 flat surfaces and see how that goes, and we can decide if there would be other adjustments that may be based on what shape you might be creating in the future. So I'm going to go ahead and close this design. And I am in my typical project folder, so you can work in your same folders that you normally do. I'll hide the data panel so I have as much space as possible. I'm going to start off with the sketch, and really what I want to do is I'm going to make this two flat surfaces that represent the 2 objects that would be theoretically the walls of the things that actually have the hinges on them, or the actual panels where you might screw in things if it's a door hinge, or the walls of the storage container that you might be creating that the hinges are connected to. So I'm going to go ahead and make a new sketch, and really the surface I do it on is not important, but I typically pick the XY plane, and there we are looking from top down. And what I'm going to do is I'm going to make 2 rectangles. Again, the shapes are not important. It's really just about having somewhere that you can connect this thing to. So I'm going to make a rectangle. I can use the rectangle button or our keyboard shortcut R on the keyboard. So that's what I'm going to do. And there it is. I'm going to go ahead and select my origin point to have a starting point. The actual sizes are not overly important, but I'll just kind of make them relatively big. So I'll do something like 60 millimeters wide by 100 long. Right. And actually, so what I'll say is if I'm going to do this as 100, I have to recognize that whatever the number of hinges I have, I'm going to have them spread across the entire thing. So if I have 100 millimeters and I'm going to have the 5 jointed hinge, then the premise is going to be that each of these joint things will be 20 millimeters in width, minus any gaps that we may decide to put in them, even though they should be relatively flush to go. So mine is going to be 60 by 100. And so there's one rectangle, that's going to be one of them. You can see it's completely locked in place. There's nothing to move because it's trapped to the origin. I'll do the same thing for another one, so I'll press R again, and I'll do the other side as well. And same thing, I will do 60 this way, and then 100 up, and there it is. And you can see now I have the 2 things. So you can see that these would be like the 2 flat surfaces. So when I design my hinges, they're actually going to be laying as if they were open, so as if the door was flat or the 2 parts were flat when they're connected. Now, not all hinges are like that. You saw in my other design, the hinges were folded over because the top of the thing was closed. So the default position was the closed top on that little treasure chest type thing. So I think that's all we need from this perspective. So I'm going to go ahead and finish the sketch. And so the idea is that I can make these into 3D, so I'm going to extrude them. I can use the extrude tool, or E as the keyboard shortcut, so I'll press E, there it is. I'll select this one. I'm going to do them individually so they make sure that they end up as separate bodies. So how thick they are is not overly important. I'm going to go ahead and say mine are 5 millimeters tall. There's the first one. Again, remember, when you use a sketch to create a 3D object, it often hides it, but because my sketch has 2 parts to it, I'm going to bring it back so I can reuse it again. I'll press E on the keyboard to extrude this. And again, notice that by default, since they're touching, it tries to join them. I want them to be separate objects, so I expect them to hopefully be two separate bodies. If I don't switch the operation, they will merge into one giant flat panel, which is not what I want. So I'm going to switch from join to a new body, and there it is. Now you can see there is that kind of line across them. So they are, in fact, two bodies. It's also 5 millimeters. I click OK, and there's body 1 and body 2. Those are the two independent pieces. Now they're very similar in what they're going to be, and so what I'm going to start as, I'm going to try to rotate to the front, and we can see this kind of flat view. And so what I want to do is draw a sketch here that's going to be the circle that's the hinge joint, that connecting thing. That's the circle that's going to go through. And again, I'm making a decision that might seem arbitrary, and it kind of is, where I'm going to, I think, have this circle centered so that the center point of the circle is somewhere on this line. In fact, if I center it exactly here, I think that will be not unreasonable. And if not centered, so that I don't want the kind of hinge, depending on what we're aiming for, we may not want the hinge to stick out from underneath here. We may want it to be flush, so I might also choose to make sure that it is tangent to this bottom line. And so that's something we have to decide on as we go. So we'll start off with that. So what I'm going to do is, to make this easier, I'm going to focus on one, and the reality is chances are I could use a similar sketch on both surfaces, but I'll start with one at a time. So I'm going to hide body 2 to begin with. And I can actually hide sketch 1, which is underneath here, because I'm no longer using this as a thing. So I'm going to make a new sketch. Instead of choosing one of these planes that are available kind of floating there, I'm going to draw on this side surface, right? So that way it's flat, and there it is. I'm going to make a circle, so I can use the circle button here, or I can use the create menu, or I can use C on the keyboard to make a circle by default. So I'll go ahead and do that. All right, so here's my circle. Again, if I use this origin point, that's kind of not going to be where I want it. I could find the midpoint, and that also is not unreasonable. You can see the little the blue triangle shows up next to the X. That means that we're at the midpoint of this tall line. And that might not be unreasonable as well. And really, if I choose it, it's going to lock it in place, so I might have to or detach that constraint if I realize it's not what I want, but we can decide from there. So I could also just make sure it's somewhere on this line. So as long as I see the blue X, that might be reasonable. In fact, I think that's what I'm going to choose to do. So instead of being stuck to the midpoint, I'm going to kind of pick somewhere a little bit off the midpoint. And so there it is. I'm going to choose a size, and the idea is that I want it to be tangent. So really, I should pick a size first, and then force it to be tangent to that bottom line, and that way the size is not dictated by the tangency, but it's actually the other way around, right? So I'm going to actually choose 8 millimeters for the size of my circle, and you can see that it overlaps. But because I didn't lock it to the midpoint, I can actually drag it, and I can move it along this thing, which is perfect. So I'm going to move it a little bit higher. You can see it's not tangent, but now we can use potentially, or try to use, the tangent constraint, right? So if I select the constraint menu, and again, the order is not overly important. I can pick the circle first, or I can click the constraint first. It's not important. If I click the tangent constraint, it knows what it needs. It needs to have a line and a curve, and then it forces the line to be tangent to the curve. If the line is locked in place like this one is, that will force the circle to move. So that's what I'm going to do. I'm going to select the circle. There it is. That's my first piece. You can see it stays blue. I'm going to choose this line. This line is locked, so the circle jumps and snaps to it, and there it is, tangent. And so you can see that the circle now is tangent to that bottom line, but it is also on this thing. It's centered on this line somewhere. It's not perfectly centered, but that's okay, and this is what we expect. And of course, depending on what diameter you chose, that might be more or less, right? But there's my first circle. In fact, I'm going to do another one as well, because the claim I'm going to make is that I do need to have the inner circle. That's going to be the part that's scooped out, right, where the pin comes through. So this inner diameter that I'm going to choose, that's how thick our pin is going to be in diameter. So I'll do the same thing. I'm going to use C to make a circle. And this one I do want centered at the same point this one is. So now that I have it, I can actually use this as a center point, which is fantastic. And then I can simply choose a diameter that's there. I'm going to choose 5. Oops, I didn't mean to click it. So I'll use the dimension tool, or D on the keyboard, choose it, and type in 5 exactly. So there it is, 5 millimeters. So you can see, and in fact, it kind of highlights automatically. You can imagine that that's the part that's going to be solid, and then everything else that's not selected, will, including chopping out all this solid, will be the hole that the pin could potentially go through once this thing is solid. One last thing I'm going to do, which would be convenient, I think I should potentially have a line, because at some stage I might want to cut out some of this so that there's not too much solid. We kind of often want a little bit of space for the thing to spin freely to be on there. So we're going to make sure that we cut that out as well. So I'm going to go ahead and use a line tool. So again, I can select it or use L on the keyboard. And there it is, L on the keyboard. And then again, I want a line, so what I'm going to do is roughly snap it to the top of the square. I'm going to snap it down. I'm going to go straight, make sure it's vertical, you can see that it has the little right angle symbol. It's not touching the line, so notice how the line is blue, so it's the thing that is not stuck, so I can move it freely. And so what I'll do is make sure that it's tangent to this circle. So I'll go ahead and do that. We can see that the other constraint that already exists is perpendicular, which means it is a 90-degree angle, which is fantastic. We'll use that tangent constraint again. I'll choose the circle and the line, and you can see how it jumps to it. And that way I'm able to kind of scoop out this portion if I need it. You can see now it's a selectable kind of area. So in the future, if I need to cut this out, I can absolutely do that. And if I needed to, I could also cut out this little piece, which I don't think we're going to do, but we could if we needed to. Right. So right now, if I change the angle, you can see, even though this is a flat drawing, the premise is going to be we could imagine extruding a lot of this out, and we would potentially end up with a circle that goes all the way through. So I think I'm happy with my sketch from a front perspective. I think it's everything we need. We can always come back and edit it if we need to. I'm going to click Finish Sketch, and there it is. And so now the next thing is let's extrude this thing all the way out and see what it looks like as we do that. So I'm going to choose just this piece. Of course, I can also choose this inner piece, but it doesn't really do anything since it's already, make sure that's not selected, so just that part. Because it's just going to be in the solid, so I could do that if I wanted to, but it's not strictly necessary. The reality is that this is all part of it. I'll do it just so it kind of gives the feeling of, oh, we're extruding the circle all the way through. So let's do that. I'm going to click E to extrude. I'm going to drag it all the way through. You can see by default it is to cut because it is passing through a solid object. And then that would leave this part. That's not what we want to do. Instead, two things. One, I want it to go all the way. And I know how long this thing is. It's 100 millimeters. So I could stretch it to 100 and say, oh, it's exactly flush. And notice how it's a negative 100 to go inward. Or something that's a little more consistent. So that way, if I ever change the size of this entire flat surface, I don't have to go back and change the size in this extrusion. I can simply say, you know what? Extrude all the way to the other side. So we're going to do two things. First, instead of making this a cut where we see red, I want it to be a join. So you can see this will be a solid object, a tube that goes all the way across. Right. So as I do that, and the second thing I want to do is I want it to go all the way up to this wall flush. So instead of choosing extent type distance, which is the typical default, I'm going to say to object. I can say all as well, but the problem is it doesn't really know what the all is because this thing, even though it has a length, it doesn't really understand that. So all is not a good choice. Instead, we're going to choose to object, and it says, okay, from this point, where do you want it to end? And notice that I can actually choose individual sides. So I'm going to pick this side right here. You see it's a little bit highlighted, and notice how it jumps exactly there, right? And there it is, flush all the way through. And notice it is 2, but that is in fact 100 if I really needed to know. It is that way. But the idea is that if I made this 150, this would stretch automatically. So I'm going to go and click OK. And there's my first extrusion. So now it looks a little bit better. Of course, this block in the middle is no good. It's kind of, you couldn't put a pin through that. So let's bring back our sketch. And now what we can do is we can select this portion and do the same extrusion, but cutting out that inner part. So let's do that. We're going to go ahead and do an extrusion. So I'm going to hit E on the keyboard. I'm going to start pulling it through so it turns red. And then this way, in fact, I can do all because it's going to be smart enough, I think, to go all the way to the end here. So instead of saying distance, let's say all. And there it is. It goes all the way to the end. It is a cut. I click OK. And there it is. And so if I hide this temporarily, you can see that almost looks sort of like the beginnings of a hinge, right? Except this is one solid tube, which would be fine if that's all it was. But of course, we want something to connect or mesh with it. And we can't do that just yet. So let's go ahead and continue with this piece by chopping it into individual pieces so that the other one that connects can go through. And so this is an arbitrary decision. Does this side have the 3? If I'm going to do 5 different hinge connecting points, am I going to do 3 on this one and 2 on the other, or 2 on this one and 3 on the other? And really that's kind of an arbitrary thing. What I'll say is, okay, I know I'm going to do 5, so I know that if it's 100 in length, I can divide that by 5, and I expect each one to be about 20. To actually save ourselves the hassle, because again, the premise would be if we change it from 100 to 150, then I would have to go and recalculate that math. I don't want to have to do that. So when we type in our numbers, we're not going to type in 20. We're going to actually type in literally 100 divided by 5. And that way, we don't have to change. If we had to change something, it would be one number because the division by 5 would automatically calculate, oh, this is actually 20 because 100 divided by 5 is 20. And that would be up to the machine to do that math for us. I am going to bring back sketch 2. So what I'm going to do is I want to scoop out a portion of this that's going to be kind of cut out. And so I'm going to select what should be cut out is the entire circle. And this part as well, because that means the other circle is going to have kind of a connecting mesh, and so that can't be in the way to like scrape against. I mean, it could be, but maybe it would be better for it not to be there. So I'm going to select this as well. So I'm holding shift, so all of that is selected. I'm going to do an extrusion, but of course, again, I'm deciding, am I doing 3 or 5? I'm going to do 3, so it's going to be 1 here, an empty space, a second one in the middle, an empty space, and then a third one at the end. So there's going to be 3 on this side and 2 empty gaps. So if I scoop like this, I could do it this way where there's 2 in this one, so an empty gap, a solid, an empty gap, and a solid, and an empty gap. But in reality, I don't actually want to I want to keep this solid. So instead of doing the extrusion from right at the beginning, what I should say is, can you start this extrusion from somewhere further along? Right? Notice it's at -19. In reality, it should be about 20 long, and it should start 20 in. So for extent type is fine, distance is fine, -20. This start, instead of being from the default profile plane, which is where our drawing is, that's the profile, we can say, how about start from some offset? And so notice when I press offset, nothing visually changes, but I get an extra option. It says, where do you want to actually start? And so I know that to go this far in, it started at -20. So it was -20 in, so that means I should probably also start at -20. So I'm going to type in over here, -20, and now see what happens, right? It says, okay, you want to begin at -20, and then you want to move -20 inward. So the result is that this part stays solid, and notice it still has the solid piece there, but this part has the wall cut out and this actual scoop cut out, right? And so I'm going to go ahead and do that and click OK. And you can see that's that first piece. Looks pretty good. The next thing I want to do is make this happen again. But do I really want to go out of my way to do the same thing offset? I could, but I can also use a pattern. And that's another thing I'm going to show just to kind of refresh everyone on patterns. And we've done patterns in another video for sketches, but you can do patterns on 3D components as well. In fact, this whole like chopped out piece could be considered a feature in 3D. So we're going to try doing that before we finish this video off. And we'll finish the rest of this in a second video. So to make our pattern, what I'm going to do is I'm going to go to the Create menu. And in fact, it is actually already right here at the top, a rectangular pattern. But just to show you, in the menu for patterns, we could do radial patterns, path patterns, and circular patterns. So rectangular patterns go in 2 dimensions. They're basically a rectangle of shapes that you could recreate. Circular pattern is the same, but it is radially around some center point. A pattern on a path is the same thing as a rectangular, but follows a path even if it is curved, which is actually a really powerful tool. And notice what they all say. They duplicate faces, bodies, features, or components. So really not just flat images, but could be 3D things as well, including cuts and joined bodies and things like that. But I'm going to choose the rectangular pattern. Notice it has to tell me, and you can always change the pattern from within the rectangular pattern menu. It even gives me the buttons here. It says, well, what are you trying to duplicate? The default is faces, so that's a face, and this is a face, and so on. But I actually want the whole scooped out part, so I'm going to change it to a feature. A feature is a little more complex, but you can actually see, if I hover over this thing, all the outside is a feature. And in fact, if I hover over this inside face, any part of it, it recognizes this whole kind of chopped out piece as one feature. You can kind of see the shadow of it as I rotate. You can see that it kind of gives it over this area. So in fact, this is what I want to duplicate. There it is, and you see it highlights it all blue. And I want to duplicate it in one direction. It says, what axis do you want to use? Now here's the only problem. Before I can do this, I must choose an axis. And we're going to try it. We can use this green one because it's at least going in the right direction. But if it doesn't work, then we can always create another axis that goes actually through the center. Let's try this green one and see what happens. And if it doesn't work, we can always swap out. And so I selected it, and there's my axis selected. The last thing it's going to say is, okay, how do you want to extend this? How do you want to distribute it? How many do you want? If I use the arrows, I'm not going to pull this one that way because I do not want to scoop it out of the solid. I instead want to scoop it sideways. And you can see what happens is it gives me kind of a preview. And it says by default, there's 3 of them. And so if I do 3 of them, it's going to say how far apart are they. You can see right now it's 38 millimeters. The extent, notice what it's going to be. The extent is distributing the pattern evenly along the full extent of the distance value specified. So it says, look, I've typed in 38 or moved to 38. It says spread out the 3 things across 38 millimeters. I could do it that way, or I could do it by spacing, which says instead the number you give it is how much space is between them. Right? If I read this little error, this thing, it says distributes the pattern instances so they are spaced at the distance value you specify. So that might be a better choice. So I'm going to choose spacing. I know the spacing should be 20, so I'm going to put 20. Not 2,000. Oh, I might have. There it is, 20. And then you can see, unfortunately, there are 3 of them, so that's why they're all flush. I'm going to change the quantity from 3 to 2. And notice what happens now is they're next to each other, which is still not correct, because if this one's 20 and this one's 20 and this one's 20 and then this one's going to be 20, then actually this one and the one that it's going to, the second one I'm creating should actually be 40 apart. So if I double this to 40, now we can see the solid one is the original that was created. The cut feature was made by doing a single cut, and the second cut, which will happen, it will be 20 or 40 away. So the 20 from this edge to here, and then another 20, so that's 40 total. End result being over here. So I click OK, and there it is. You can see that's our hinge. The first part of our hinge anyway. So I'm going to hide this sketch. You can see this complete solid thing, and that's pretty good for a first try. So I'm going to stop this video. Our next video we'll do the other half, which will be pretty much the same thing, but just the other two. And then the last step we'll do in that video as well is to make a pin that goes through them all. And really, I'll do a very simple pin, but the reality is you can make pins as complex as you need to if you want to have a cap on it to make it easier to pull out and things like that. I'll see you. Oh, first, let's make sure to save. Of course, it's really important to do. And so we'll go ahead and call this hinge example. I'm going to save it. It's in my T3 CAD folder. I'm going to save it once. There it is. And then I can stop here. I'll see you in the next video.